everyone, welcome to my channel. Today in this video, we are going to see about the next ISS module made as a portal from inside the ISS to the vacuum of space. The Quest Airlock. Let's start the video. Imagine a gateway that seamlessly connects two worlds, each with its own distinct language and tools, yet both essential for survival. This portal, engineered with precision and foresight, serves as a bridge for adventurers clad in different armors to step into the unknown. In the realm of space exploration, this passageway enables astronauts to venture into the vacuum of space. Equipped for their mission, regardless of the suit they wear, it stands as a testament to human ingenuity, ensuring that exploration can continue without the constraints that once limited access to the cosmos. This innovative airlock embodies the spirit of collaboration and adaptability, vital for the continuous journey beyond our planet. The Quest Airlock serves as a primary gateway for spacewalks on the International Space Station ISS, designed to support both American and Russian spacesuits. Its creation addressed the need for a versatile airlock that could facilitate extravehicular activities for astronauts, regardless of the spacesuit they wear. Enhancing the ISS's operational capabilities, Quest remains a crucial component for spacewalks, enabling maintenance and scientific missions. This airlock is integral to the ISS, showcasing advanced engineering that ensures the safety and efficiency of astronauts venturing into space. The Quest Joint Airlock, a critical component of the International Space Station ISS, serves as the primary gateway for astronauts to venture into space during extravehicular activities. Now let's see the parts of the Quest Airlock. EVA hatch. The EVA extravehicular activity hatch is one of the most vital components of the Quest Airlock, located at the nadir side of the module. This hatch serves as the entry and exit point for astronauts conducting spacewalks. The EVA hatch is designed to maintain the integrity of the station's atmosphere while allowing safe passage for crew members. It ensures a secure seal against the vacuum of space and is equipped with mechanisms to equalize pressure, making it possible to open and close the hatch safely during operations. Nitrogen tanks. The Quest Airlock features 4 nitrogen tanks strategically placed around the module. These tanks play a crucial role in maintaining the proper pressure and atmospheric composition within the airlock. Nitrogen is used to purge the airlock of any contaminants and to help balance the atmospheric pressure before and after spacewalks. Toolboxes. Attached to the exterior of the Quest Airlock are 2 toolboxes, labeled as Toolbox 1 and Toolbox 2. These toolboxes contain essential tools and equipment that astronauts might need during these EVAs. The placement of these toolboxes on the airlock's exterior ensures the astronauts can easily access them without having to re-enter the stations. The contents of these toolboxes are carefully selected based on the specific requirement of each spacewalk, including tools for repairs, scientific instruments, and safety devices. ESP2 External Storage Platform 2. Adjacent to the Quest Airlock is the External Storage Platform 2. It is a module that will be attached to the ISS in upcoming space shuttle missions. This platform provides additional storage space. ESP2 is located at the port side of the airlock, making it easily accessible for astronauts conducting EVAs. This sophisticated piece of engineering measures 5.5 meters in length and 4 meters in diameter, with a mass of 9,923 kilograms. The pressurized volume of the airlock is 34 cubic meters, and the overall cost for its construction and deployment was $164 million. In the configuration diagrams here, its location is highlighted in the red, showing that it is connected to the starboard side of the Unity Node 1. The airlock is centrally located, allowing for easy access from different parts of the station. This central position is crucial for coordinating EVAs and for ensuring that astronauts can quickly and safely transition between the interior of the station and the vacuum of space. The Quest Airlock was manufactured by NASA, Boeing. NASA tested and launched the module into space. NASA, as a lead agency for ISS, oversaw the airlock safety and carried on the launch. Boeing, a major aerospace manufacturer and contractor for NASA, played a significant role in constructing and fabricating and testing Quest components. This partnership underscores the collective effort and expertise from multiple organizations to design, build, and deploy critical infrastructure like Quest, an important unit in the space station made for EVAs, supporting the ISS's functionality and ongoing scientific research in space. On July 12, 2001, Space Shuttle Atlantis launched into space for STS-104 from NASA's Kennedy Space Center in Florida, the usual launch location for space shuttles, carrying the Quest Airlock module and 4 nitrogen tanks to the ISS. The STS-104 crew consisted of Commander Stephen W. Lindsay, pilot Charles O. Hober, and mission specialists Michael L. Gernhardt, Janet L. Cavandy, and James F. Rayleigh. Once in orbit, the shuttle's cargo bay doors open to reveal the Quest airlock at the aft end and the nitrogen tanks at the forward end. The Quest airlock, crucial for spacewalks, consists of the equipment lock and crew lock, allowing the use of American EMU suits. Though capable of accommodating Russian Orlan suits, these are primarily used with Russian airlocks in the ROS for Russian EVAs. The nitrogen tanks were later installed onto the Quest to provide necessary resource for extravehicular activities. The Space Shuttle Atlantis mission STS-104 marked a significant milestone for the International Space Station ISS. Its primary objective was the delivery and installation of the Quest airlock, a vital component for future spacewalks. This pressurized module, designed as a two-chambered structure, would become the main passage for American astronauts venturing outside the ISS. The mission involved a well-coordinated effort. After Atlantis docked with the ISS, astronauts Gernhardt and Rayleigh embarked on the first spacewalk. Their task was to prepare the Quest airlock for transfer. Canadarm2, the robotic arm of the ISS, then played a crucial role by meticulously retrieving the airlock from the shuttle's payload bay and maneuvering it to its designated position on the starboard side berthing port of the Unity 1. This was the first task of the Canadarm2 after its installation to the ISS on STS-100. With the airlock precisely placed, Gernhardt and Rayleigh completed the installation by connecting power cable during their spacewalk. Subsequent spacewalks focus on equipping the newly installed Quest airlock. This included attaching 4 high-pressure gas tanks for critical operations, installing handrails for astronaut safety during external work, and outfitting the airlock with other essential equipment. Notably, the third spacewalk was conducted from within the Quest airlock itself, demonstrating its functionality and readiness for future use. The successful delivery and installation of the Quest airlock by STS-104 marked a turning point for the ISS. This new airlock became the primary path for American extravehicular activity (EVAs). Enabling astronauts to safely enter and exit the space station for crucial maintenance and scientific endeavors. Astronauts prepare for spacewalks in the Quest Airlock's equipment lock, made of high-strength aluminum and steel alloys. Here, they wear their extravehicular mobility unit suits and use systems like the battery charging assembly and fluid pumping unit (FPU) to ensure the suits are operational. They then move to the crew lock, connect to the umbilical interface assembly, perform final safety checks, and store their inner airtight hatch. To prevent decompression sickness, astronauts use either the camp-out method or the in-suit light exercise protocol, depressurizing the airlock to 4.3 psi before exiting through the hatch for extravehicular activity (EVA) or spacewalk. After the spacewalk, astronauts return to the crew lock, repressurize the airlock, and disconnect from the umbilical interface assembly before moving back to the equipment lock to remove their EMA suits. The suits are then cleaned, refilled, and recharged using high-pressure gas tanks, ensuring readiness for next EVA. This sequence, supported by the airlock's robust construction, ensures safety and efficiency of the ISS spacewalks, maintaining the crew's readiness for future missions. In conclusion, the Quest joint airlock is a necessary component of the International Space Station, facilitating safe and efficient spacewalks since its launch on July 14, 2001. This module, with its EVA hatch, nitrogen tanks, and accessible toolboxes, ensures astronauts can perform essential maintenance and scientific tasks outside the station. Its strategic central location and additional storage via the external storage platform 2 enhances its functionality, making it indispensable for ISS operations. The Quest Airlock exemplifies the ingenuity and dedication that drives space exploration, continuing to support humanity's quest for knowledge and discovery in the harsh environment of space. I hope this video on the Quest Airlock of the ISS was interesting and informative. I'll meet you in the next video with another interesting ISS module. Take care, bye.